Myocardial infarction is tissue death or necrosis caused by the local lack of oxygen due to an obstruction of tissue's blood supply. Damage and death of heart tissue occur due to the build-up of the plaque in the coronary artery, blocking the blood flow and the oxygen to the heart. Look at the coronary artery. In the coronary artery, the plaque is present with the fibrous cap. Once the cap ruptures, blood clot will form around the ruptured area and then blocking the artery. In normal myocardium slide, we can observe the central nuclei and also the cross striations and the ping of intergalactic discs are also present. This is acute myocardial infarction slide. In 1 to 2 days of myocardial infarction, we can observe the myocardial fibers have dark red contraction bands extending across them. Also, the myocardial cell nuclei undergo karyolysis and almost disappear. There is increasing loss of striation so that we cannot see the striations, and some neutrophils begin to infiltrate the myocardium as a result of acute inflammation. In recent myocardial infarction, we can also observe the extensive hemorrhage after reperfusion and the necrosis of the myocardial fiber. Also, there is loss of cross striations due to the necrosis and the nuclei are not present. In 3 to 4 days of myocardial infarction, many neutrophils undergo cardiohexis and the cell nuclei are no longer visible. This is an acute myocardial infarction of 3 to 4 days. There is more extensive neutrophilic infiltrate with prominent necrosis. And also, there is hemorrhage. In 1 to 2 weeks of myocardial infarction, healing of the infarction becomes more prominent with the presence of capillaries, collagen, macrophage, and these are called granulation tissue. Also, there is normal myocardial fibers at the top. In this slide, there is pale white, which shows the extensive collagen deposition, and also the inflammation has disappeared.
There are 3 types of pneumonia, which are bronchopneumonia, lobar pneumonia, and interstitial pneumonia. For the bronchopneumonia, it's a pus-forming peribronchiolar inflammation caused by inhalation of pathogen. Lobar pneumonia is the inflammation in the air sacs of alveoli which fill with fluid or pus. And lastly, interstitial pneumonia often present with autoimmune conditions. A. Show the location of the lungs and airways in the body. B. Show the microscopic pictures of normal alveoli that consist of bronchiole, the tiny airways, and alveoli, the air spaces. And for the C, shows alveoli with pneumonia, which fluid and pus fill air space contains bacteria and blood cells. There are also an inflammation in alveolar wall.
This is the normal microscopic slide for lung, and for the alveolar walls are thin, which are composed of single layer of simple squamous epithelium. Between the alveoli, there is also a thin layer of connective tissues and numerous capillaries that line with simple squamous epithelium. Bronchioles are lined by a slated columnar epithelium, and for the blood vessel surrounding each air sacs of the alveoli.
the inflammatory slide for lobar pneumonia. This slide is from our previous lab season. The alveolar wall are thickened, which congested capillaries in the alveolar septum consists of the connective tissues and the capillaries. In the alveolar lumen, it consists of the macrophage and the neutrophil. These pictures show alveolar septum widening. There is also a blood vessel surrounding each air cells of the alveoli.
Meningitis is an inflammation of the meninges that surrounds your brain and spinal cord. Meninges consists of 3 layers: the outermost layer called dura mater, the second layer called arachnoid mater, and the last one, pia mater. Subarachnoid space is located between arachnoid mater and pia mater. Subarachnoid space is filled with cerebrospinal fluid. In normal condition, subarachnoid space should be clear. This is the slide from previous lab session. This is subarachnoid space and this is cortex. In acute meningitis, subarachnoid space is filled with inflammatory cells that is composed of neutrophil and macrophage. This is Virchow-Robin space that extends from the subarachnoid space to the cortex. It becomes the route for inflammatory cells to travel from subarachnoid space to the cortex. So this is the normal view of appendix, where we can find mucosa, submucosa, muscularis, and then the outermost layer is the serosa. Okay, what actually happens in acute appendicitis? In acute appendicitis, we will have inflammation basically in mucosa layer, but the inflammation also can extend to submucosa and then muscularis. Here, at the mucosa, we can find ulceration and then with fibrino-purulent exudate.
Okay, so in the ulceration area, you can find neutrophils. But if the ulceration already extends to submucosa and muscularis, you will find also neutrophils at both layers.
So this is our slide from the lab session in 4 times magnification, where we can see the ulceration of mucosa. As you can see here, the mucosa layer is not in quite a good shape because of the ulceration. The next one we have submucosa, and then muscularis. The outermost part is that serosa.
Okay, so this is the lumen, but it is smaller than it should be. And then in this lumen, there is pus. The pus that fills the lumen will be discharged into peritoneal cavity, and then will lead to extensive peritonitis.
Okay, so this is the slide from lab session in 100 times of magnification, where we can find the inflammatory cells, which is neutrophils, because this is acute inflammation. So, as you can see, there are a lot of neutrophils. You can see like small dots all over this slide. What will happen in absence of appropriate treatment is that complication will occur. For example, septicemia and then shock, and will lead to death.